let's get going. It makes me more happy than you can ever imagine to see so many people here at a talk about manual testing. This is thrilling for me. My name is Alex. I work for Bradex. I'm a product owner and I'm head of our test consulting. And I'm going to talk to you today about manual testing. The actual topic is exploratory testing and session-based test management, but those are words that not everybody knows what they mean, and I'm going to explain what they mean and hopefully sell you on why this is so important, and you should spend some time thinking about it and training your teams on it. Okay, really quick introduction. The company I work for, we do individual software development for customers, enterprise customers. We've always had a big focus on quality. Some of you may recognize me as being as a part of the Jubilee team. I'm often talking about automated testing and how important that is. And like I say, I'd like to tell you today about manual testing, exploratory testing, how to use it and how you can plan and organize it. What? I hear you say, aren't you the Jubilee girl? Aren't you always talking about how cool automated testing is? Yes, I am. But automated testing isn't the only thing that you should be doing as part of your test strategy. Manual testing is really important as well. Why is that? If it was early in the morning, I'd start asking philosophical questions about why we test. But I'm going to give you an answer that I like to work with. It's not from me. I like using the definition of testing that it's gathering information with the intention of informing a decision. So the information can be, it works, it doesn't work, it feels funny, is this a problem? That can be all those kind of things. And if we're talking about gathering information, then if you think about it a bit further, you can't plan for everything. There's no way in the world you can know every single test case in advance. And even if you did know all of them in advance and you started writing them up or even automating them, I guess, you would only ever spend time writing them. You'd probably never get the chance to actually execute them. And we have a problem as well, which I'm going to come back to a few times. You can only plan to tests based on what you know. And it's a sad thing that we don't know everything. And some of the things we think we know aren't necessarily true. And I'm reading the book Explore It by Elizabeth Hendrickson at the moment. And she said, if you're exploring in any sense, but in a testing way as well, and the map and the territory differ, you believe the territory. You don't believe what somebody said, this is the map. You believe, no, there is a mountain here. That's what we've got. So we're gathering information. And within various testing communities, there's a difference in vocabulary and semantics used, whether we say we're talking about testing or we're talking about checking. And if we're talking about checking, that means that we're doing things to see, does it have the intended behavior? The things that we think we know and that we can plan. And that is very, very important. There are tools available for it. That's exactly the kind of thing that you want to be able to do in an automated fashion. Checking again and again, does this still work? Is everything okay? Like I say, it's a continuum anyway, and both ends are very important. So this is important, but the testing is the exploring. It's looking for, are there any other risks that we've not thought about? Is there something that we don't know? And that's something that you can only do in an unscripted way, because that's the nature of the problem. And I'll get to how we can do that in just a second. So here, this is the world in which I usually spend a lot of my time living and talking about. But this world is incredibly important, and I said it in the speaker pitches today. It's important for everybody. This isn't just something that a tester has to be able to do. It's something that a developer should do as well before something gets committed. Otherwise, you get that horrible, the tester comes and says, did you even look at this? And of course, the answer is yes, but maybe not in the way, maybe I didn't think far enough, maybe I didn't explore far enough, and I would not suggest that any of you would do that, but maybe people you know who aren't here, and you can go and help them. Why it's so dangerous only to be on the checking side, I have a couple of videos. I downloaded them, so it's not YouTube. If you know them, try not to be like, oh, I know this one. This is what happens. That would be cool, and I hope the sound works.
This is an awareness test.
Oops. Me and my Mac. There we go.
How many passes does the team invite?
Who saw the bear? Okay, this video isn't the best quality either, so it's okay. There he is. If you can't see it again, I'll show you on my Mac later. Okay, that actually comes from looking out for cyclists. That's number 1. Video number 2 is from the quality, in terms of quality, a bit better. I love that guy crawling. Okay, so 2 really rather cool videos. The problem that they tell us about is something called observational blindness. If you are looking for one thing, you will focus only on that, and you will miss really obvious other stuff that you wouldn't otherwise miss if you weren't focusing. So the narrower our view, the wider the ignorance. And this is something that is in all aspects of our life. Like I say, those are 2 adverts for cyclists. If you're focusing on cars, you're not looking for cyclists. But it really affects us in testing as well. One thing that plays together with that as well, everyone knows this, errors avoid paths that we test a lot. So where we have lots of tests, we probably won't find errors there anymore. That doesn't mean that we shouldn't have those, for example, automated, because it is nice to know that there aren't any errors. But that's not just the place that we can look, because they're going to be in other places as well. Sorry, I'm just trying to get rid of the mouse. And I'm failing. Go away. That's problem 1 if we stay at that checking end. Problem 2 is that we're ignorant. And I don't mean that as an insult. This is a quote from Donald Rumsfeld, and I always think this is really, it sounds really crazy. There are things we know, there are known unknowns. We know there are some things we do not know, and there are unknown unknowns. We don't even know we don't know them. This idea of orders of ignorance, there are 3 or 4 of them, I think. I've only got the most relevant ones here. The 0th order is that we provably know something. We can prove that we know it. And that's something that you can have a scripted test for, that you can prove again and again, we know that this works like that. First order ignorance is we are aware of the things that we don't know. So we can write a test to do that. That can be manual or it can be automated. We'll ask the questions that will give us the knowledge to say, aha, now we know that. And of course, things that were first order ignorance at some point go into 0th order ignorance because we provably know them. The big problem is second order ignorance. We don't even know what we don't know. There are risks out there. We have a net. If you think about testing as some kind of a net of security, a safety net, there's going to be holes in it, and we probably don't know where they are. And that is where exploratory testing comes in and why it is so important, because it helps us find those risks. So it's not scripted, and then everyone goes, yay, so I just click around, right? I just go crazy. Not quite. The picture of the jigsaw, is rather relevant. How do you do a jigsaw? Do you write down in advance how you're going to solve it? Do you document every single thing you're going to do? I'm first going to take this piece and attach it. You don't. When you do a jigsaw, you look at the pattern. You think, oh, okay, maybe I'll start with the outside. And you pick up another piece that's got an outside on it, and you turn it that way, and you turn it that way. And every time you say, does it fit, does it not fit? Every question is a test case. Every single time you say, does this fit, does this not fit, it is a test case. And what you do sometimes as well is you go, ooh, there's a big blue area. I think I'm going to switch and go to the blue area because you can't concentrate on the other stuff anymore, or because you've just had the breakthrough. That's not documentable in advance. So it's not just having a click around. It has a process and it has a systematicness. That's not a very good English word. It's systematic, and it's not ad hoc. I try and get a zombie picture in every set of slides I do. Last year it was me because I'd lost my voice. This year it's because you can't just be a zombie and click around. It's not monkey testing, it's actual systematic testing. The idea of exploratory testing is that design, execution, and analysis all happen at the same time. You don't plan everything in advance and then do it and then do a result report. You're doing it in an emergent way. The test is going to change depending on what you see. You observe, you change what you're going to do next. That is exploratory testing. That doesn't mean that you can just throw everything you know about testing or don't know about testing out of the window. You've got your normal test design practices. If you like working with personas, you can use personas. If you like working with boundary case, decision tables, anything you want to use, that's still in your toolbox, but you're not saying in advance exactly how you're going to do it. And it is situational and emergent. So like with the jigsaw, the puzzle is going to help you to solve the puzzle. And you're not going to use the same way of solving one puzzle that you'll use to solve another. If you have a jigsaw puzzle that's full of flowers, that'll be a different way of solving that than one that's a picture of the Sahara Desert. Different puzzles require different approaches. And any time that you change what you're going to do next based on what you've just observed, that's a good sign that you're exploratory testing. And it sounds hard, but actually, anyone who hasn't drunk too much at the Nestor bar is generally capable of it. So today, yes, tomorrow, perhaps no. It's something that we do naturally as humans. We question things and we notice things. Another definition that I read about exploratory testing is it's what you have to do if a product jumps out of the bushes and challenges you to a testing duel. Right here, right now, no documentation, because I'm going to ask a question. How many people work in projects where all of the requirements are well documented in advance? Okay, that makes me feel better. So sometimes you get people that say, well, I can't start testing because I don't know what it should do. We never test. You can use this to find out what the product already does as well, which especially with Legacy, the guy who wrote that he's gone. It kind of works. Find out. That's what we use exploratory testing for as well. So we use it to find out unknown unknowns. We can use it to find out how the software works. I've said here when the specifications aren't detailed, just in case anyone had put their hand up, but yeah, usually they're not. When you need to find important information quickly. The great thing about doing this is that you're not chained to a test script that says you have to do this and then this and then this. You do something, you notice, oh, that looks a bit weird. I wonder what will happen. Oh, okay, I found a bug. You can do that quickly and find out in a short amount of time, does this feel okay? Does this feel bad? I'm not a great fan of test script writing if it's not going to be automated. The idea of writing something that I'll do manually and doing it in such a level of detail that I could have automated it is crazy to me. And I like having the human factor in software as well. I come from a humanities background. It's what I do. And we avoid that observational blindness that makes us not see moonwalking bears or 21 changes. So I'm just going to assume that I've totally sold you all on exploratory testing and why we need it. And can well imagine you might be asking, okay, Alex, this is good, but how? How do I do this? Well, there are three very good questions. How do I know what the program should do? especially if there isn't it should do this and then this and then this. How do you know what's right? How do you know what's wrong? What should I even test? And yeah, what am I going to do with this black box that I've been given? Well, you can give talks, one can give talks just on these things. My idea today is that you know what they are, that you can go and read and look up on them. The first thing that we use in exploratory testing is the idea of sources. That's anywhere where you can get information. And that can be the craziest places you like. So that can be, obviously, any specifications you do have, knowing that anything in any process that you've ever done, what is on that document is likely no longer the exact truth. But it can be a source that you put into your source pile to find out what's going on. What's really good is to talk to your marketing and sales guys and see what they've been promising. That's a good source of information. And then after you've cried, you can go and test for it. Ask your customer, work with your users. If you know nothing else about the product, have a look what's in its menus. Look through the context menus. What does it say I can do here? What are the buttons saying I should be able to do? Build yourself a picture of that. All of these sources give you a mental model that you can then test against and refine. And obviously, if your mental model is not exactly what is documented or what the developer said he'd done, then you know you might have a problem and you might need to talk. To do this, we use oracles. The oracle problem is, how do I know if something is right or if something is wrong? But an oracle is just a heuristic, a fallible method of knowing whether something is a problem or not. This is where the mental models come in. This is where your own gut feeling comes in. Most of us have been working with software and around software for a long enough time to know when something smells fishy. And it can be, sometimes it's hard to define. It's just, it doesn't feel right. Or when I press this button, the computer goes, okay, that's not a good sign. Or everything starts to heat up, my phone gets hot in my hand. These are all things that if you were asked later, you might find it difficult to define, but they're things that feed into this mental model. And there's the idea of consistency as well. It works differently here than it does here. Is that supposed to be the case, or is that a problem? And we have a lot of other heuristics as well to guide the testing, and I'm just going to give you a couple of examples. In the references at the end, I've got some links to cheat sheets and other heuristics. So the easiest one is CRUD. If you have something where you can create things in your database or whatever, create it, read it, update it, delete it. That is one way of finding out what things are going on for that test. It's a good way of structuring your tests. I like Goldilocks. Everyone knows the story of Goldilocks, right? So you have something that's too big, it's too small, it's just right. I read a really funny joke on Twitter. It does not come from me. It says, a tester goes into a bar and orders a beer, orders 7,000 beers, orders -1 beer, and orders 1 a blah. So playing with data like that, following the data around, what can I do with it? I can enter it, I can search for it, can I export it? There's the idea of using nouns. It's hilarious, right? This guy at the front is like, this is so funny. Idea of using nouns and verbs, putting them together in a table and seeing what comes out. Some of it won't make sense, but it'll give you ideas to guide your testing, to say, okay, I'm not just going to sit there and click around. What kind of things can I use to help me? And they have a great deal of mnemonics. Some of them make sense. This used to just be hiccups, and then somebody added F on the end, and now it's hiccups. This is the consistency heuristic. Is it consistent with how it used to be? What our image should be, what other people do, what we're claiming it should do, what our users expect with the product as a whole. And I do like the F because we all know that where a bug has once been, more bugs will come. So it's worth looking when you're exploratory testing to see if the kind of things that go wrong frequently have gone wrong again. And there are, like I say, there are tons and tons of things on this, and some of them are in the references. So it's not completely unguided. There are good ways of going about this when you say, how am I going to test this? How do I start? So exploratory testing has a great deal of advantages, at least if you ask me. I think it's something that everyone can and should be able to do. It's less preparation. You can do it if you don't have your complete specifications. And incredibly importantly, especially in agile areas, it's adaptable to new information very quickly. You find something out, you can go and say, okay, we're going to explore that. We can do this now. Also, it's more interesting. There's nothing more boring than manually clicking through a script you've done once already on Windows, and now you have to test it on Linux. Oh, God, it's not fun. It does have disadvantages, though, and if you're in very strict or processes that need to be audited, likelihood that you'll find this a bit of a difficulty is there. It's not reviewable, it's not reproducible. You can't say, do exactly that test once again. The idea is to repeat your thinking, not the steps, to avoid the problems that you're going to have just with checking. And if you have a low availability environment, if you have a test machine that you can only get onto for 15 minutes every 4 weeks, then you're probably going to want to do tests that you definitely know are going to find the things you might need or the highest risk. So that's maybe somewhere where it's not so good. And the other problem, one problem that I really had with this and couldn't find a way to introduce it into our teams was, when do you do this? How? Do you just say, hey, everyone, spend the next 6 months exploratory testing? Doesn't go down well with the customer. And that's when I learned about session-based test management, which I'll introduce to you now. The idea is that this is a way of organizing and reporting on exploratory testing. So for those environments that do need a bit more documentation of how you're doing things and what you're doing, this might be a way of getting there. It consists of 4 things: charters, sessions, notes, and debriefing. And I'm going to give you a bit of an insight how we do this, but it's quite flexible. I know that other teams do things in a slightly different way. It's a cycle. You define a charter, and I will get to examples of each of these things. A charter is the area you're going to look at. You prioritize and assign them, and it's important that this happens again and again. So even if you do, depending on what kind of scale you're looking at, a day or over a sprint, even if you said yesterday this was important, everyone knows something can change, and something else is more. I don't think I've ever had it that something became less important, but there are things that come in that become more important, and it's important to be able to, I've said the word important so much I don't know what it means anymore, to be able to deal with that and reprioritize. Then we have our session. We go down the rabbit hole. I couldn't find an open picture of a rabbit, so it's a meerkat. So go the meerkat hole. While you're in the session, you observe and you note, and this is actually a picture of my desk when I'm doing exploratory testing. I've got some colored pens, I've got my headphones because I like to listen to music while I'm doing it, and I've got my notes, and somewhere there is also a computer. Then you get back together with your team, who may or may not resemble ducks, debrief, and then go back into the charter definition and prioritization. The idea of a charter is to say, I want you to explore a certain area with these resources, and the resource can be time, or it can be things like use security attacks or use different types of data to discover, and a lot of the time discover is just discover information or find questions. Sometimes it can be to find out if we have problems between the communication between this area and that area, if you have a very specific question. And charters can come from all kinds of places. And anyone who's listening well, if stakeholders ask questions and they say, well, will it be able to do that? And someone says, sure it will. It's already implemented in the API. And you go, okay. Obviously, that's important for my stakeholder. So I'm going to form that as a charter that I'm going to at least consider testing for this. Risks is a great way of doing this. I read recently, again, in the book by Elizabeth Hendrickson, about the nightmare headline game. The idea is you come in for your stand-up meeting or your team meeting, and you say, okay, you're in the shower, you come out, reading the paper, flicking through, and you see a giant headline. And the headline is about your software. What does it say? What is the worst thing that that headline could say? Once you've got that, you work back from that to say, okay, where are the risks, and what charters can we use to find out whether those risks are true or not? I'd advise against things like alien invasions, harder to test for. But the idea is that you can really work with your greatest fears to find out whether they're going to come true or not. They are defined in advance, but more can always come onto the pile, and they get prioritized before every session. The idea of a session is that it is completely uninterrupted a time box. The guidelines say 30 to 120 minutes. We usually do about 1 hour and 15 to 1 hour and a half. And when it says uninterrupted, that means email off, no meetings, shut the door. This is incredibly difficult to actually do, but you have to aim for that level of uninterruption. You are down the rabbit hole. And if you find another hole, which will happen, this is not part of my charter, then the way we do it, there's a slight difference that you can do here, is to say, okay, that sounds interesting, that could be a new charter for the next session. Otherwise, you can end up not actually looking at the thing you were supposed to be looking at. And the space of 90 minutes usually isn't that critical that you would have to say, hey, wait, we need to change everything again. In that session, you use your heuristics, you create tests, you execute them, and while you're doing it, you write notes. There are tools available that you can use to document exploratory testing. We don't do anything except maybe screenshots, save log reports. That works well enough for us. How do I feel about it? And a very important metric, or two very important metrics, are how long did it take me to set this up, and how long could I actually spend testing? And how long did I spend on my actual charter, and how long did I spend looking at other things, if you are doing the way that you allow that? Like I say, we don't. But if you are doing that, that's an important ratio roughly to get out. The idea is that for the next session, or the next set of sessions, that you'll try and reduce at least the test to set up. Obviously, there's no point in spending 90 minutes setting up and then you have 3 minutes to test. That's a bit sad. Debrief, we use a mnemonic. Proof, what happened? What was achieved? What did I do? What blocked me? Again, incredibly important to get the most out of a session like this. What still needs to be done? Do we need new charters? Do we need to call a stop to everything because, oh my God, nothing works? And how do I feel about this? I know talking about feelings is difficult, but it's important because your feelings are often, I feel scared about this. I feel that I'm going to be called by an angry customer if we release this. That is important to say. Or I feel good about this. We do test days, so we still do some manual testing before a release, and we usually put that into a test day, which can look something like this. We find out who's going to take part, not just developers, it can be customers, stakeholders, anyone else who's interested. The more the merrier. I know that I spoke to, I forget his name, but another guy from Atlassian, they call it Bug Bash, right? At least where he was. We call it a test day, and we get everyone involved, and we really align ourselves to a program so that all meetings are cancelled and that no one tries to disturb us. Couple of questions. When do you enter bugs? Do you spend all your time in the session, you find a first bug, and then you say, oh, I'm going to have to reproduce this now, and then spend the next 90 minutes trying? Or do you note things down, spend a little bit of time thinking, okay, I think if I do that and that, then I'll be able to reproduce this later. I like to take the second approach because usually the first bug you find feels like the worst until you find the second. And that level of perspective is usually quite nice. So we just take notes of things, discuss them, and then at the end of the day we say, okay, we're going to put a bug in for that and actually fix it, or we're going to put a bug in for that and say, it's just there, we're documenting it, however we want to do it. To kind of go full circle, the mix is important. I said at the beginning, automated tests are hugely, hugely important. You might, your speaker pitch was saying another thing. I'll be interested to hear your talk. I think they're very important to have your regression tests and to have new acceptance tests coming in regularly. But in a sprint as well, or in whatever phase you're using, to use some exploratory testing as well, both from a developer who's done it and from someone who's looking at this from just a test perspective. And before a release, we do still use some test checklists that are semi-scripted, but we are moving more and more away from that because they're boring to maintain, they're boring to execute, and they're based on risks that are 5 years old. Not helping us. We use exploratory testing days using session-based test management. Like I say, it's the mix. It's all part of your strategy. You can't just go to one or the other end. And every team will do it slightly differently. But I hope that you found that that is a good thing to put in your toolbox, and that might be helpful to you. And I'd like to say thanks and ask if there's any questions. Mm.
So, and of course you can give hints that usually testers know the software better than like test manager, for example. So, what can you, I mean, I'm sure you came across it before.
Yeah, that's really where the heuristics and things and cheat sheets come in. There's a couple of mnemonics and a cheat sheet here, and if you Google a bit, so the idea is you don't just have to go, really don't know. There are things like the Goldilocks, or especially a lot of the mnemonics take you on tours, like feature tours. Can I do a functionality tour? Can I do a big feature tour? Can I do a crazy user tour? Using personas and things. What would my granddad do with this software? You know, looking at things like that. And the other thing, what I like to say, this is the other topic that no one ever likes to talk about, is read the documentation. Pretend that, yeah, I know, it's crazy, right? Have a look at what the documentation says. I don't mean the specification, I mean a user documentation that hopefully exists. And see whether you think, okay, well, you can do that here, you can do that here. My experience is that once you get rolling, the ideas come and they won't stop coming. It's just the initial hurdle of blank slate, tabula rasa, where do I start? And those kind of cheat sheets are really good. There was also something I found that Microsoft had done where they'd formalized it a bit more and given some real hints about where to start. I don't think it's in these lists, but it should be quite easy to find as well. So my advice would be to use some cheat sheets, and it's only going to be that hurdle because the ideas will come and come. Yeah? We debrief with the whole team and the product owner, because that's the important thing to say. I understand that you think that this bug is the worst thing to ever happen, but someone else will have another perspective, and okay, we'll look at that maybe later, but it's not the most important thing. So we do it with the whole team, because sometimes it can be, I couldn't reproduce this, it happened once, and I don't even know what happened, and someone else might go, hey, I had that too, and then you get that feedback from everyone that you're like, okay, we have some serious instability issues, maybe we should look at that. So we do that with the whole team, but we kind of time box that as well, because otherwise you can get lost. Okay, I think the time is probably nearly up. If there's any more, did you have a question? Yeah?
Do you think the developer is really possible for developer to just do this creative art of finding bugs? Because if you program it, you know what to test and
So I think yes. The slightly flippant answer would be, developers are clever too, they'll manage, but I know what you mean. You
just fix something you already thought of?
So there's the idea of you're only, as a developer, maybe you'll only test what you exactly know. I think that that's something you can get past a little bit with practice. And I'm not suggesting that someone who's just developed a feature should be solely responsible for exploratory testing for it. Definitely not. If you're we have our developers help us with the testing as well on the exploratory level too, and we always make sure that someone else is looking at it. So I think, yes, it's learnable, and even if a developer only uses the heuristic for familiar problems, or what is the last thing that I want to hear and stand up tomorrow when Alex comes in and says, the tests broke, something went wrong. Just even those two things, what's happened to me before that I want to cover my behinds about, and what would I not want to hear tomorrow? I think just those two things is definitely possible for everyone, and the rest is probably based a bit on how you feel about it, but I think that minimum is probably achievable. I have hopes. Okay, I think time is up. I'm hanging around for the rest of the day. Begonia, no, somebody wanted me to tell you about the party tonight. It was Denis. In the program, there's a party with the band Cool Down. It starts at 8, is that right, Denis? At 8. We realized in the program it doesn't look like it's really exciting. It really is. It's a lot of fun, and yeah, it would be great to see everyone there. So thank you for listening.